Hi and welcome back to freesciencelessons.co.uk. By the end of this video you should be able to describe what's meant by resistance. You should then be able to calculate resistance in a circuit. Now over the last few videos we've seen that electricity involves the transfer of energy in an electric circuit. The cell contains chemical energy which is transferred to electrical energy and is carried by the current. And remember that the current is simply a flow of electrons around the circuit. When the electrons pass through a component, such as a lamp, the electrical energy is transferred to other forms of energy, such as light and thermal energy. We use potential difference to work out the energy transfers involved. The cell has a potential difference of 9 volts, so the current is carrying 9 joules of electrical energy per coulomb of charge. The potential difference across the lamp is also 9 volts, telling us that all of the electrical energy carried by the current is transferred by the lamp into other forms of energy. So the question we're looking at is, why does this energy transfer take place? What about components causes them to transfer energy? And the answer is resistance. As we've said, an electric current is a flow of electrons through a conductor, such as a metal wire. As they move, electrons collide with atoms in the metal. Electrical energy is transferred into other forms of energy, for example thermal. The resistance simply tells us the potential difference required to drive a current through a component. In other words, how much energy is required to push a coulomb of charge through. I'm showing you here 2 circuits containing different lamps. A current of 1 ampere is moving through both circuits. In lamp A, the current is being driven by a potential difference of only 1 volt. This tells us that only a small amount of energy is required to drive the current through this lamp. So lamp A is a low resistance lamp. In lamp B, the current's being driven by 10 volts. This means that a relatively large amount of energy is needed to drive the current through lamp B. Therefore, lamp B has a higher resistance than lamp A. It simply takes more energy to drive the current through lamp B. So can you see that the idea of resistance is actually fairly straightforward? Now you could be asked to calculate the resistance of a component. It's easy to do this, we simply use this equation. The resistance equals the potential difference in volts divided by the current in amperes. The unit for resistance is the ohm, and you could be asked that. Here's the symbol for the ohm. Now you're not given this equation in the exam, so you need to learn it. Now many students prefer to use a triangle for equations, so here's a triangle for this equation. So we're going to work out the resistance of the 2 lamps that we saw before. Lamp A has a current of 1 ampere and a potential difference of 1 volt. Putting these into the equation gives a resistance of 1 ohm. Lamp B also has a current of 1 ampere, but this has a potential difference of 10 volts. Putting these numbers into the equation gives us a resistance for lamp B of 10 ohms. Now in the exam you could be asked to work out the potential difference needed to produce a certain current. To do that, we need to rearrange the equation for resistance like this. The potential difference in volts equals the current in amperes multiplied by the resistance in ohms. Here's a typical question. Calculate the potential difference across the lamp. We can see that the current is 0.5 amperes and the resistance of the lamp is 50 ohms. So to calculate the potential difference, we multiply the current by the resistance. 0.5 multiplied by 50 gives a potential difference of 25 volts across the lamp. Remember, you'll find plenty of questions on calculating resistance in my revision workbook, which you can get by clicking on the link above. Okay, so hopefully now you should be able to describe what's meant by resistance. You should then be able to calculate resistance in a circuit.